Hi students, today we're going to start chapter 13, which is one of my favorite chapters. It's conic sections. Graphing conic sections are really fun. It's parabolas, circles, ellipses, and hyperbolas. We get away from all that function notation, and we really just get to kind of use equations to create shapes. I'm going to use PowerPoint today, which hopefully allows you to see the graphics a little bit better than you could see them when I use my whiteboard. I'm still going to do the whiteboard a little bit. You're welcome to give me feedback on what works for you, because I know everybody's got a different setup at home. Some people have great great screens where they can see everything I'm doing, and some people maybe are trying to watch on their phone and they can't see as well. So let me know what's working for you and what's not. Let's get started. All right, so here we've got conic sections. Basically, why they're called conic sections is because they're slices of a cone. And this cone is actually two cones. You see in red those cones. And then you take a plane, which is a two-dimensional object like a sheet of paper, and you take a slice of that cone. In the first image, the slice of the cone gives you a parabola. In the second, if you slice it horizontally, you can get a circle. If you slice at a funny angle, you can get an ellipse, which is a stretched circle. And if you slice totally vertically, you get a hyperbola, which is basically two parabolas. So the parabola, circle, ellipse, and hyperbola are the shapes in yellow that you see. The stuff in red is the cone, and the stuff in blue is the plane that is slicing through that cone. So these are what conic sections are. And they each have their own graph and their own equation. So the first conic section I want to go over is the parabola. Now we've graphed parabolas, but we've graphed them as functions. So we use that f of x notation. Here we're going to drop the f of x notation. This chapter 13, none of these are expected to be functions, which means there's no input-output. It's just a relationship between x and y. Okay, so they don't have to pass the vertical line test anymore, and we also don't have to solve them for y. We can write them in any form we want. All right, so when we think of parabolas as equations and not as functions, we've looked at the parabolas that open up and down, and those were functions, but they weren't one-to-one functions, meaning for x equals 1 and x equals -1, you could get the same y value. Right? So they weren't one-to-one, and that meant we couldn't take their inverse and get a function. But we can still take their inverse and get a new equation, okay? So we can still take the inverse of these guys, but their inverse is no longer what we call a function. It doesn't pass that vertical line test. All right, so the inverse of the parabolas that we've used before are also parabolas. They're just going to open left and right instead of up and down. Okay, let's look at the equation of parabolas that we worked on so far. So the vertex form of a parabola is the form we like to keep it in, where we say y equals, sometimes we have an a lot of times a is just 1. That makes it skinnier or wider. And then in parentheses, we have x minus h squared. And remember that h is the horizontal shift of our vertex. And then we add a k, which is the shift up and down. So hk is the vertex, and that a just tells you how wide or how narrow that parabola opens up. Okay, so that's the vertex form of parabolas that we've used so far. All right, hopefully you guys are really familiar with that. Nothing there is new for you, okay? Let's take a look at, okay, now let's take a look at some different graphs. And I want to do that using the Desmos software. I don't know if you guys have checked out the Desmos software, but it's really helpful to make your graphs look really clean. Definitely try graphing stuff by hand, because that's what you're going to have to do on tests, and it's just a good skill to have. But then you can check your work with Desmos, and it helps to manipulate stuff in Desmos so that you can kind of see how graphs change, okay? So let's take a look at Desmos. All right, so this first graph that we have is just y equals x minus 1 squared minus 3, okay? So remember that minus 1 is really the minus h, so h is 1, so notice our vertex, the x coordinate is at 1, and then the minus 3 is our y coordinate for the vertex, so our vertex is at positive 1, negative 3. All right, that should seem familiar to everybody. That a, if you don't understand how the a works, imagine a is 5, it just makes this guy much, much more narrow, okay? So that's how that a works. Oops, is it just makes that thing more narrow, or if a is, say, 1/2, it just makes it wider, okay? So that's how the a affects the graph, if you weren't familiar with that. Now let's look at the inverse function. So remember, to take inverses, we just literally replace the x with a y, replace the y with an x, right? So it's that same exact equation, just where you saw y, write an x, where you saw an x, write a y. And so the second equation is the inverse. All right, let's move it over. So the inverse equation is just that guy sideways. Okay, let's take a look at where our vertex is of this new graph. Our vertex is right here at negative 3, 1. Okay, so now the y shift is what's happening to the y. Y minus 1 means we're shifting positive 1. And the x shift, negative 3, is the last thing that's happening. Okay, so the x's and y's flip. So it flips the way the vertex is affected also. Okay, and remember, the inverse function is just every point gets flipped over this line, y equals x. That's our inverse function. Okay, so we're not going to have to convert one function to its inverse, but instead we want to be able to work with, if we're just given one of these guys, we want to be able to graph it. Okay, so let's take a look back at that PowerPoint. Okay, so on the left here, we've got the vertex form of the parabola that we're used to. The y equals a x minus h squared plus k. The vertex is our h and our k. All right, those are the xy coordinates of the vertex. The axis of symmetry is a vertical line. So this guy opens up or down. And the rate that it opens up or down, meaning how wide or narrow it is affected by A, right? And then if A is positive, we open up. If A is negative, we open down, okay? So those are the parabolas we worked with so far. The other type of parabola is where the y coordinate is squared and the x coordinate is not squared. So to see what these look like, you want to say x equals all that other stuff. X equals A times y minus k squared plus h. Notice how the h and the k are switched, so that k is still our y coordinate and h is still our x coordinate, okay? These open sideways, and that a, if the a is positive, then you're going to open to the right in the positive x direction. If the a is negative, you're going to open to the left in the negative x direction, okay? Notice that since these guys aren't functions, we don't have to solve for y. Instead, we're using just whatever form of the equation is going to show its characteristics. So in these sideways parabolas, we actually have x equals, and that's because it shows us the important characteristics of the graph so that we can graph it easily. Let's maybe take a look at some more of these sideways graphs. Okay, So we have this sideways graph. It opens to the right because our A here is actually a positive one. I could change that. If we make that A, say a negative, it flips the graph. If we make it a negative 4, it narrows the graph. Okay, so see how the negative versus the positive flips your graph. Okay, just like if we had this same equation or a similar equation, but a vertical parabola, if we make the A negative, it flips it. So the negative direction for both your horizontal and your verticals are going to be in the negative X or the negative Y direction. If we've got a positive A, it's going to open to the right or it's going to open up. Okay, so positive opens to the right or opens up, negative opens down or opens left. Okay, and you know that you're going to open up and down if it's your X coordinate that's squared. Okay, you open up, down if the X is what's squared. You open left, right if the Y is what's squared. Okay, and the coordinate that affects your vertex, remember it's just the thing that's closer to it. So whatever is in parentheses, if you've got an X in parentheses with your number, then the opposite of that number is your X coordinate for the vertex. If you've got a Y in parentheses with your number, then the Y, whatever's in there in parentheses with your Y is going to be the Y coordinate for your vertex, the opposite of that. Okay? Let's go back to our PowerPoint. Okay, we're here in our PowerPoint. All right, so definitely take your time, go back through those equations and make sure you understand the different pieces of them and how they work so that you can see an equation with numerical values there and make the graph. You want to be able to see an equation where H and K have actual numbers and you want to be able to draw that graph, all right? Let's go over some more questions that you might end up having. So what if your parabola isn't in vertex form? Hopefully you guys have seen this before from chapter 11 and know what to do. If it's not in vertex form, you need to complete the square, okay? Now we're gonna learn a lot of other equations too, other graphs. How do we know that our equation is the equation of a parabola? Okay, well, the one way you always recognize that you have a parabola and not some other shape is that one variable will be squared, the other variable won't be squared. So if X is squared and Y is not squared, you have a parabola that's opening up or down. If Y is squared and X is not squared, you have a parabola that's opening left and right. So that's how you know you have a parabola. And if you have a parabola, then you know you need to get it into vertex form by completing the square, okay? So let's do an example of completing the square for one of these parabolas. Okay. I'm going to write this one out on the whiteboard. So here we've got equals x squared x plus 6. We identify it as a parabola because the x is squared, the y is not squared. okay? And remember, it has nothing to do with what's on what side of the equation. All that stuff can be moved around just with addition and subtraction, right? So remember how to complete the square. What we basically want to do is look at these two terms and modify this last term so that this is a perfect square, okay? So to do that, let's give ourselves a little bit of space here so that we can modify that term by adding 0. Okay. So I just gave us a little space, and in here we're going to add 0, but we're going to do it in a way that gives us a constant term to make this a perfect square. And we know our perfect square is that, maybe I'll write it over here. Our perfect square, so if we have some x plus a constant term squared, that's a perfect square. When that gets multiplied out, we end up with x squared plus 2bx plus b squared. So we know that whatever our constant term is here, we have to divide it by 2 and square it to get this guy. Right? That's what completing the square is. So let's go back over here. We've got a 4. So we're going to divide that by 2. We get 2. 2 squared is 4. So we know that what we need to add here is a 4. But we can't just go adding 4. We have to also subtract 4 so that we're really only adding 0. Okay? Now we've got this stuff here that is a perfect square. All right. So now by adding this special 0, we've made this stuff a perfect square, and we can fold it back up. To this. Because when you multiply out x plus 2 squared, you end up with x plus 4x plus 4. So this factors down to that. And then this remaining term, we add them together and we get a plus 2. Right? So that's completing the square. We took this equation up here. We recognize that it is a parabola because the x is squared, the y is not squared. We perform the completing the square operation to get it into our vertex form. Okay? This is our vertex form, and we like this form because we see that our vertex here is actually a negative 2, positive 2. Our vertex is 2, positive 2, because remember, it's x minus h. So this is x minus negative 2. So that's why our vertex, our x coordinate is a negative 2 plus k, so our y coordinate is a positive 2, right? Once we know that that is our vertex, then we can go ahead and actually just graph this equation. We have all the pieces that we need. We have our vertex is negative 2, and our a, which just tells us how far we open up, is equal to, what's a? A is equal to 1. All right, there's just a 1 here. Okay. Now, since the x is squared and not the y, that means we open up, down. Since a is positive, we're going to open up. Okay. So we can take a look at what this graph will be. So this 2, 2 here tells us our vertex is at negative 2, 2. We know that we're opening up at a speed of 1. So that means the first step to the right and to the left just pops us up 1 and 1. Another way to do this, once you've identified your vertex, you can just plug in an x value to the left or to the right of that vertex to kind of guide you in opening your parabola. okay? So let's go through those steps again. You get your equation. We have our equation. Identify it as a parabola, but it needs the square completed. Complete the square so that you can ID the vertex, and then ask yourself, which direction is this opening? Okay, sideways or vertically. We know this one was vertical, and positive, that's up. All right, we graph it by plotting our vertex, and then you can either use that A to tell you how far you're going to go up for 1 unit to either side, or you can use that A, or you can just plug some number into our equation, find another point on this graph to help guide us with the opening of the graph. Okay. Hopefully you guys remember doing that. That's, what is that, chapter 11, okay? All that quadratics, chapter 11. All right, so now you know if the parabola isn't in vertex form, you got to complete the square. You'll know it's a parabola because one variable is squared and the other is not. And here you have in purple, this is an equation that's not in vertex form. And then in pink there, that's what that would look like in vertex form. Okay. So those are parabolas. You should remember working on those quite a bit. Let's do one more example with a parabola that opens left-right. Okay, so let's take a look at this equation and graph this guy. Y squared plus 6y minus x plus 8 equals 0. At first, you might not recognize what this is, but you see that our y is squared, we have a y squared, and our x term is not squared. Yes, there is this other y there, but that's okay because we could wrap it into this y. So y is squared, x is not squared. That tells us we have a parabola. All right, we've got a parabola, so we know we need to complete the square on the y, okay? And we know that in vertex form, the piece that isn't squared, we want actually on the other side of the equal sign, okay? So I'm going to add x to both sides just to kind of get that x out of the way and closer to vertex form. So I'm adding x to both sides of the equal sign. And then to make it more normal, I'm going to switch everything. So x all right, so I moved the x over here, and then I just wrote this stuff there and this stuff here, okay? So now does it look closer to our parabola? Except you see that this parabola is going to open sideways because the y term is squared, the x term is not squared. Okay. Next step is to complete the square. So I'm going to give myself space. I know that the constant term I need is this constant term, 6, divided by 2, 3, squared. So I know I need a 9 here. So I can just go ahead and add a 9. Oh, my pen's breaking. Let me get another pen. All right, I got a pen that works. 6 divided by 2 is 3. 3 squared is 9, so we need a 9 right here. To balance that 9 out, we have to also subtract 9. So that stuff in green, I just added 0, but in a special way. So this stuff's going to be a perfect square. It's going to factor to y plus 3 squared. And you can check that. Y plus 3 squared will multiply to y squared plus 6y plus 9. Okay. This stuff that's left over, negative 9 plus 8, is going to give us a negative 1. And that all still equals x. Now our vertex, remember the thing in parentheses with that variable is the one that affects the y. So now it's a -3 is our y coordinate, and -1 is our x coordinate. So it's the opposite when it's close. Y is close to a +3, so the y coordinate is a -3. It's the opposite when it's close. The x is the -1. So our vertex is -3, -1. Sorry, -1, -3. And we are going to open sideways, but the A is a +1 again. So we're going to open to the right. All right. And if I want to kind of figure out how fast or how slow this is going to open, I can plug in some points. So I could plug in y when y is let's say 0. So I can plug in y equals 0. You guys see that? So if y equals 0, I'll plug that into here. 0 plus 3 is 3. 3 squared is 9. 9 minus 1 is 8. So when y equals 0, x equals 8. We can see that we're going to open just about that fast. So just by plugging in any other point, it'll help guide the opening of your parabola. Okay. And it's going to be symmetrical on the other side, so we know this guy's going to open about like that. Okay. So that's a parabola that opens sideways. Let's move on to circles. If you guys have more questions on parabolas, check out your textbook. Definitely check out your textbook. And past that, you want to check out the, you just email me and I can show you more things. Check out your textbook. There's lots of graphs there. There's lots of doing this complete the square. Email me. I can point you to more directions. Use Desmos to see how these things change and understand how the equation relates to the graph. Okay. Let's move on to circles. Okay, graphing circles. So a circle has a radius, which is this at the center of it. And all the points on the circle are an equal distance from this radius. That distance we sometimes call D, or a lot of times we call R for the radius, okay? So that's kind of what defines a circle, is all points on a circle are equal distant from a single point at the center of the circle. A circle gets its equation from the Pythagorean theorem. Pythagorean theorem is the formula for the distance between 2 points. So remember when we were calculating the distance between any 2 points, we use that Pythagorean theorem. So the distance between 2 points is equal to the square root of the distance between the x's squared plus the distance between the y's squared. So now what happens is we're not just using any random 2 points. One of those points is going to be our center, and it's going to be fixed, okay? And now we just want all the other xy's that solve that equation for a fixed distance or radius, okay? So we use that Pythagorean theorem formula and we get the circle formula. So the center of our circle, we're going to use the letters H and K just like we did for the vertex of our parabola. H and K are representing the center of our circle. And then X and Y are all the points that are the same distance away from that center of the circle. Okay. So take a look at that equation on the bottom right-hand side and how that is the equation of the circle. So H, K, and D are all going to be fixed numbers here. And just the x and y are going to change. And they're going to be all the x and y points that are the same distance d from that center point hk. Here's another way to look at the equation of the circle. Instead of d, a lot of times we use r. And we also don't really like to have that square root function. So let me go back really quick. See that equation on the right-hand side, the square root of x minus h squared plus y minus k squared equals d. Square both sides of that equation, and we get the equation of a circle. So we just square both sides because we don't like seeing that square root. It's really awkward, but it's the same relationship between all the pieces. So here you can see this circle. Its center is hk. That distance, d, is the radius. So that's the radius of the circle, or the distance between the center and every single point on the circle, every x, y coordinate that makes that circle. And it's that triangle, that Pythagorean theorem, that gives us our equation. So hk, the coordinate hk, is the center of our circle, and it's going to be a fixed value. Okay, those are going to be real numbers. R is the radius, which is the distance from the center. That's also going to be a fixed real number in each equation. Then the x, y are the only things that are actually going to be letters, and those are going to be all the pairs of x, y's that satisfy the equation, meaning they're all the points that are a distance of r from the point hk. Right? Take some time to think about that and to really, really look at that equation of a circle there. Now let's go to Desmos and look at some more graphs. Here we go. So we've got our first graph here. X squared plus y squared equals 25. So there, h and k are the center. H and k are both 0. Now our radius, what's our radius? It's 5. So you see here, it looks like 25, but remember, it's the x term squared plus the y term squared equals the radius squared. So our radius isn't 25, our radius is actually 5. Oops. Okay, 25 and 5 squared are the same thing. So realize, even though it said 25, that's really 5 squared, so our radius is 5. Now, if we wanted to shift the center of that circle but keep the radius the same, you can look at our second equation here. Think about how is this going to shift our circle. So our radius is still going to be the same, 5 squared, so our radius is 5, but y minus 1, so to get the same effect, our y is going to have to increase by 1, and x plus 3, so to get the same effect, our x is going to have to decrease by 3. So this is going to be the same circle, but the center is now going to be at -3, +1. Let's take a look. See how the center moved from here? It moved left 3, up 1. Okay. We can also make the radius smaller. If we want our radius to be 3, then we'll just say equals 3 squared. Okay. If we want our radius to be 2, we can say equals 4 squared. Or sorry, 2 squared. If we want our radius to be 1, 1 squared. Okay. So take a look at these and see how y is -1. If I make it a +1, that's to the negative side of the y. Same thing with the x. If I switch from a positive to a negative, it moves us over to the right. You can use Desmos to play with this, and you want to sort of understand how this equation causes this circle to move. Okay. So that's the equations of a circle. If your center is at 0, 0, it's going to look like this. Here our center is at 3, -1. We can also have You know, maybe one of our equations has a shift and one doesn't. Sorry, one of our variables has a shift and one doesn't. So something like that. This guy in green, you see our center is at 3, 0. Get rid of the other ones. This guy in green, the center of our circle is at 3, 0 because the x has a shift, has to increase by 3 to get the same result, but the y has no shift. Okay. Our radius here is 3 because 3 squared is 9. All right. So play with this and get an idea of how to graph these equations. You might also want to do something like, with this equation here, let's look at some of the points on this graph. One of the points is 3, 3. So you want to go in and ask yourself, does that satisfy this equation? 3 minus 3 is 0, plus 3 squared equals 3 squared, okay? So you can use this and kind of see how all the points on this circle actually satisfy this equation, okay? So that's the graphing of these circles. Let's go a little deeper in. So what if our circle isn't in standard form? You notice how we have to have those perfect squares. The x and the y are grouped with something and then squared. Well, if it's not in standard form, just like the parabola, we have to complete the square. And we actually have to do this once for the x variables and once for the y variables. So you're going to get really good at completing the square after this section. Okay. The way you want to start is put all the terms that have x and y's on one side and put your constant term on the other side, so it's out of the way. Okay. How do we know we have a circle? We know how to identify a parabola, right? One variable squared, one isn't, but how do we know we have a circle? You don't actually know you have a circle, but you know you have one of three things: a circle, an ellipse, or a hyperbola. So far, we've only got circles. The way you can identify that you have one of these three things is that both variables are squared. Okay? If both variables are squared, then you've got a circle, an ellipse, or a hyperbola. And once you complete the square, it will become clear which one of those things you have. So let's do an example here. This is a circle that is not in standard form. And we'll complete the square, and we will see how to graph it. Okay, so here we have our equation: x squared plus y squared plus 6x minus 2y minus 6 equals 0. X and y are squared, so we know we don't have a parabola. So it's got to be a circle or a hyperbola. We'll talk about those later. So we're going to complete the square on x and complete the square on y so that we get it in that special form that we can identify the shape of this circle. So if we want to complete the square on x, we need to group these x pieces. If we want to complete the square on y, we group these y pieces. And that -6 is just modified depending on what versions of 0 we add or subtract. Okay, so let's reorganize our terms. A little space, actually. And I can put this -6 on the other side by just adding 6 to both sides. Okay, so I did a -6 here, add 6 to both sides, gives it over here. Right. So I've left this little space to complete our square, and we do it just like we did it before. So x squared plus 6x, we know that this term, this 6, divided by 2 and square it is 9. We know we need a 9 here. So I'm going to add a 9. My pens are all dying on me. So we add a 9. What did I do wrong here? Can't just go adding 9s. We have an equation. We can add 0, or we can add the same thing to both sides. So I could say plus 9 minus 9, and then that minus 9 is in the way, so I'd add 9 to both sides, get it over here. Or I can just add 9 to both sides. Okay. So here, because we're not in that function notation, because we know we want a constant term over here anyways, instead of doing a plus 9 and a minus 9 on the same side, I take that minus 9 and just add 9 to the other side. Okay. Now, this thing here is going to be our perfect square. It's going to factor to x plus 3 squared. And if you haven't already noticed, when you factor this to a perfect square, it's always going to be x plus whatever this is divided by 2. Okay. Now let's do our y. We've got y squared minus 2y. The constant term we need is this divided by 2, so -1, squared positive 1. Same thing, I can do plus 1 minus 1 and then ignore that -1, or I can do plus 1 on both sides. All right. So I added 9 to both sides, I added 1 to both sides, I'm allowed to do that. Now this guy is going to complete the square. And we get y minus 1 squared. Now let's just see what's left on the other side. A 6 plus a 9 plus a 1, and that's going to give us 16. Okay. So now we've completed the square for our circle, and we can see that our center is at 3, 1. Sorry, -3, 1. And our radius is 4, right? This is our radius squared, so our radius is 4. So then we can go and look at the graph of that guy. Here we are. That's our center. And our radius is 4. So from here, we'll go down 4. 1, 2, 3, 4. So we know we have a point 4 down. We know we have a point 1, 2, 3, 4 over, 4 up, 4 over this way, and 4 up this way. Okay. So we found our center, which is at -3, 1. Okay. And then it's just easiest to go 4 down, 4 to the right, 4 up, and 4 to the left. Okay. And identify those points and then just make those into your circle. Okay. So that's our circle. Its vertex is at -3, or its center is at -3, 1. So if this point is 4 up from there, this is going to be -3, 5. If this is 4 over, this is going to be 1, 1. This is 4 down, so this is -3, -3. Okay. And this point here is 4 to the left, so that's going to be -7, 1. Okay. You don't have to mark those points, but it really helps if you mark those points to see that you know your radius is 4, because we are 4 away from there. And then you draw your circle the best you can, and technically all the other points on this circle are 4 away from there. Okay, so that's our circle. Okay. So there we recognize that we had a circle because the x and the y are squared. So we knew we did not have a parabola. we had to complete the squares. So we grouped our x terms, gave ourselves the constant term we needed, and compensated for it. Completed that square. Grouped our y terms, gave ourselves the constant terms we needed, compensated for it, completed the square. Now that we have our x and y terms in complete squares, we grouped all our constant terms on the other side of the equal sign so that we could see our vertex, or sorry, our center and our radius. Once we identify our center and our radius, we graph our center, and then we just go we go the radius distance out from there and start marking points to complete that circle, right? So that's completing the square and graphing the circle. All right, that was one of the harder examples. Definitely go look in your textbook, look at these examples, plug in some x's and some y's that make the equation true so that you understand how the equation gives you the graph. Okay, let's look at that last slide just one more time so that you guys can see that. All right, so here's our last slide. If our circle's not in standard form, we need to complete the square twice. Put the x and y on one side, constant terms on the other. You know it's a circle and not a parabola if both variables are squared. Here was our example. Everything was all on one side. We reorged it, completed the square, and it looks like this. From here, we could see our vertex was at -3, 1, and our radius was 4, and we were able to graph that circle. Again, your textbook has some other examples where the square is completed, the vertex, the center is at 0. Those are good places to start and to look at those circles. Definitely get started on your homework right away. Let me know if you have questions or if you want me to go over any more examples. Don't hesitate to reach out to me and ask questions. I hope you enjoy this section and good luck with everything.